1910 Subpart T Appendix C. Alternative conditions under 1910.401a3 for recreational diving instructors and diving guides, mandatory. Appendix C to Subpart T of Part 1910. Alternative conditions under Section 1910.401a3 for recreational diving instructors and diving guides, mandatory. Paragraph A3 of Section 1910.401 specifies that an employer of recreational diving instructors and diving guides, hereafter, divers or employees, who complies with all of the conditions of this appendix need not provide a decompression chamber for these divers as required under Sections 1910.423b2 or C3 or 1910.426b1. Equipment requirements for rebreathers. The employer must ensure that each employee operates the rebreather, i.e., semi-closed circuit and closed circuit self-contained underwater breathing apparatuses, hereafter, SCUBAs, according to the rebreather manufacturer's instructions. The employer must ensure that each rebreather has a counterlung that supplies a sufficient volume of breathing gas to their divers to sustain the divers' respiration rates, and contains a baffle system and/or other moisture separating system that keeps moisture from entering the scrubber. The employer must place a moisture trap in the breathing loop of the rebreather and ensure that the rebreather manufacturer approves both the moisture trap and its location in the breathing loop, and each employee uses the moisture trap according to the rebreather manufacturer's instructions. The employer must ensure that each rebreather has a continuously functioning moisture sensor and that the moisture sensor connects to a visual, e.g., digital, graphic, analog, or auditory, e.g., voice, pure tone, alarm that is readily detectable by the diver under the diving conditions in which the diver operates, and warns the diver of moisture in the breathing loop in sufficient time to terminate the dive and return safely to the surface. And each diver uses the moisture sensor according to the rebreather manufacturer's instructions. The employer must ensure that each rebreather contains a continuously functioning CO2 sensor in the breathing loop and that the rebreather manufacturer approves the location of the CO2 sensor in the breathing loop. The CO2 sensor is integrated with an alarm that operates in a visual, e.g., digital, graphic, analog, or auditory, e.g., voice, pure tone, mode that is readily detectable by each diver under the diving conditions in which the diver operates, and the CO2 alarm remains continuously activated when the inhaled CO2 level reaches and exceeds 0.005 atmospheres absolute, ATA. Before each day's diving operations, and more often when necessary, the employer must calibrate the CO2 sensor according to the sensor manufacturer's instructions and ensure that the equipment and procedures used to perform this calibration are accurate to within 10% of a CO2 concentration of 0.005 ATA or less. The equipment and procedures maintain this accuracy as required by the sensor manufacturer's instructions, and the calibration of the CO2 sensor is accurate to within 10% of a CO2 concentration of 0.005 ATA or less. The employer must replace the CO2 sensor when it fails to meet the accuracy requirements specified in paragraph 1F3 of this appendix, and ensure that the replacement CO2 sensor meets the accuracy requirements specified in paragraph 1F3 of this appendix before placing the rebreather in operation. As an alternative to using a continuously functioning CO2 sensor, the employer may use a schedule for replacing CO2 sorbent material provided by the rebreather manufacturer. The employer may use such a schedule only when the rebreather manufacturer has developed it according to the canister testing protocol specified below in Condition 11, and must use the canister within the temperature range for which the manufacturer conducted its scrubber canister tests following that protocol. Variations above or below the range are acceptable only after the manufacturer adds that lower or higher temperature to the protocol. When using CO2 sorbent replacement schedules, the employer must ensure that each rebreather uses a manufactured, i.e., commercially prepacked, disposable scrubber cartridge containing a CO2 sorbent material that is approved by the rebreather manufacturer, removes CO2 from the diver's exhaled gas, and maintains the CO2 level in the breathable gas, i.e., the gas that a diver inhales directly from the regulator, below a partial pressure of 0.01 ATA. As an alternative to manufactured, disposable scrubber cartridges, the employer may fill CO2 scrubber cartridges manually with CO2 sorbent material when the rebreather manufacturer permits manual filling of scrubber cartridges. The employer fills the scrubber cartridges according to the rebreather manufacturer's instructions. the employer replaces the CO2 sorbent material using a replacement schedule developed under paragraph 1H of this appendix, and the employer demonstrates that manual filling meets the requirements specified in paragraph 1I of this appendix. The employer must ensure that each rebreather has an information module that provides a visual, e.g., digital, graphic, analog, or auditory, e.g., voice, pure tone, display that effectively warns the diver of solenoid failure when the rebreather uses solenoids and other electrical weaknesses or failures, e.g., low battery voltage. For a semi-closed circuit rebreather, a visual display for the partial pressure of CO2, or deviations above and below a preset CO2 partial pressure of 0.005 ATA, and for a closed circuit rebreather, a visual display for partial pressures of O2 and CO2, or deviations above and below a preset CO2 partial pressure of 0.005 ATA and a preset O2 partial pressure of 1.40 ATA or lower, gas temperature in the breathing loop, and water temperature. Before each day's diving operations, and more often when necessary, the employer must ensure that the electrical power supply and electrical and electronic circuits in each rebreather are operating as required by the rebreather manufacturer's instructions. Special requirements for closed-circuit rebreathers. The employer must ensure that each closed-circuit rebreather uses supply pressure sensors for the O2 and diluent, i.e., air or nitrogen, gases and continuously functioning sensors for detecting temperature in the inhalation side of the gas loop and the ambient water. The employer must ensure that at least two O2 sensors are located in the inhalation side of the breathing loop, and the O2 sensors are functioning continuously, temperature compensated, and approved by the rebreather manufacturer. Before each day's diving operations, and more often when necessary, the employer must calibrate O2 sensors as required by the sensor manufacturer's instructions. In doing so, the employer must ensure that the equipment and procedures used to perform the calibration are accurate to within 1% of the O2 fraction by volume. Maintain this accuracy as required by the manufacturer of the calibration equipment. Ensure that the sensors are accurate to within 1% of the O2 fraction by volume. Replace O2 sensors when they fail to meet the accuracy requirements specified in paragraph 2C3 of this appendix, and ensure that the replacement O2 sensors meet the accuracy requirements specified in paragraph 2C3 of this appendix before placing a rebreather in operation. The employer must ensure that each closed-circuit rebreather has a gas controller package with electrically operated solenoid O2 supply valves, a pressure-activated regulator with a second-stage diluent gas addition valve, a manually operated gas supply bypass valve to add O2 or diluent gas to the breathing loop, and separate O2 and diluent gas cylinders to supply the breathing gas mixture. O2 concentration in the breathing gas. The employer must ensure that the fraction of O2 in the nitrox breathing gas mixture is greater than the fraction of O2 in compressed air, i.e., exceeds 22% by volume. For open circuit scuba, never exceeds a maximum fraction of breathable O2 of 40% by volume or a maximum O2 partial pressure of 1.40 ATA, whichever exposes divers to less O2. And for a rebreather, never exceeds a maximum O2 partial pressure of 1.40 ATA. Regulating O2 exposures and diving depth. Regarding O2 exposure, the employer must ensure that the exposure of each diver to partial pressures of O2 between 0.60 and 1.40 ATA does not exceed the 24-hour single exposure time limit specified either by the 2001 National Oceanic and Atmospheric Administration Diving Manual, the 2001 NOAA Diving Manual, or by the report entitled Enriched Air Operations and Resource Guide published in 1995 by the Professional Association of Diving Instructors, known commonly as the 1995 DSAT Oxygen Exposure Table, and determine a diver's O2 exposure duration using the diver's maximum O2 exposure, partial pressure of O2, during the dive and the total dive time, i.e., from the time the diver leaves the surface until the diver returns to the surface. Regardless of the diving equipment used, the employer must ensure that no diver exceeds a depth of 130 feet of seawater, FSW, or a maximum O2 partial pressure of 1.40 ATA, whichever exposes the diver to less O2. Use of no decompression limits. For diving conducted while using nitrox breathing gas mixtures, the employer must ensure that each diver remains within the no decompression limits specified for single and repetitive air diving and published in the 2001 NOAA Diving Manual or the report entitled Development and Validation of No-Stop Decompression Procedures for Recreational Diving, the DSAT Recreational Dive Planner, published in 1994 by Hamilton Research Limited. Known commonly as the 1994 DSAT No Decompression Tables. An employer may permit a diver to use a dive decompression computer designed to regulate decompression when the dive decompression computer uses the no decompression limits specified in paragraph 5A of this appendix and provides output that reliably represents those limits. Mixing and analyzing the breathing gas. The employer must ensure that properly trained personnel mix nitrox breathing gases and that nitrogen is the only inert gas used in the breathing gas mixture. And when mixing nitrox breathing gases, they mix the appropriate breathing gas before delivering the mixture to the breathing gas cylinders, using the continuous flow or partial pressure mixing techniques specified in the 2001 NOAA Diving Manual, or using a filter membrane system. Before the start of each day's diving operations, the employer must determine the O2 fraction of the breathing gas mixture using an O2 analyzer. In doing so, the employer must ensure that the O2 analyzer is accurate to within 1% of the O2 fraction by volume. Maintain this accuracy as required by the manufacturer of the analyzer. When the breathing gas is a commercially supplied nitrox breathing gas mixture, the employer must ensure that the O2 meets the medical USP specifications, Type 1, Quality Verification Level A, or aviators breathing oxygen specifications, Type 1, Quality Verification Level E, of CGAG 4.3-2000, Commodity Specification for Oxygen. In addition, the commercial supplier must determine the O2 fraction in the breathing gas mixture using an analytic method that is accurate to within 1% of the O2 fraction by volume. Make this determination when the mixture is in the charge tank and after disconnecting the charge tank from the charging apparatus. Include documentation of the O2 analysis procedures and the O2 fraction when delivering the charge tanks to the employer. Before producing nitrox breathing gas mixtures using a compressor in which the gas pressure in any system component exceeds 125 pounds per square inch, psi, the compressor manufacturer must provide the employer with documentation that the compressor is suitable for mixing high-pressure air with the highest O2 fraction used in the nitrox breathing gas mixture when operated according to the manufacturer's operating and maintenance specifications. Employer must comply with paragraph 6E of this appendix unless the compressor is rated for O2 service and is oil-less or oil-free. And employer must ensure that the compressor meets the requirements specified in paragraphs I-1 and I-2 of section 1910.430 whenever the highest O2 fraction used in the mixing process exceeds 40%. Before producing nitrox breathing gas mixtures using an oil-lubricated compressor to mix high-pressure air with O2, and regardless of the gas pressure in any system component, the employer must use only uncontaminated air, i.e., air containing no hydrocarbon particulates, for the nitrox breathing gas mixture. Compressor manufacturer must provide the employer with documentation that the compressor is suitable for mixing the high-pressure air with the highest O2 fraction used in the nitrox breathing gas mixture when operated according to the manufacturer's operating and maintenance specifications. Employer must filter the high-pressure air to produce O2-compatible air. The filter system manufacturer must provide the employer with documentation that the filter system used for this purpose is suitable for producing O2-compatible air when operated according to the manufacturer's operating and maintenance specifications. And employer must continuously monitor the air downstream from the filter for hydrocarbon contamination. The employer must ensure that diving equipment using nitrox breathing gas mixtures or pure O2 under high pressure, i.e., exceeding 125 psi, conforms to the O2 service requirements specified in paragraphs I-1 and I-2 of section 1910.430. Emergency egress. Regardless of the type of diving equipment used by a diver, i.e., open-circuit scuba or rebreathers, the employer must ensure that the equipment contains, or incorporates, an open-circuit emergency egress system, a bailout system, in which the second stage of the regulator connects to a separate supply of emergency breathing gas, and the emergency breathing gas consists of air or the same nitrox breathing gas mixture used during the dive. As an alternative to the bailout system specified in paragraph 7A of this appendix, the employer may use, for open-circuit scuba, an emergency egress system as specified in section 1910.424 C4, or for a semi-closed circuit and closed circuit rebreather, a system configured so that the second stage of the regulator connects to a reserve supply of emergency breathing gas. The employer must obtain from the rebreather manufacturer sufficient information to ensure that the bailout system performs reliably and has sufficient capacity to enable the diver to terminate the dive and return safely to the surface. Treating diving-related medical emergencies. Before each day's diving operations, the employer must verify that a hospital, qualified healthcare professionals, and the nearest Coast Guard Coordination Center, or an equivalent rescue service operated by a state, county, or municipal agency, are available to treat diving-related medical emergencies. Ensure that each dive site has a means to alert these treatment resources in a timely manner when a diving-related medical emergency occurs. And ensure that transportation to a suitable decompression chamber is readily available when no decompression chamber is at the dive site, and that this transportation can deliver the injured diver to the decompression chamber within 4 hours travel time from the dive site. The employer must ensure that portable O2 equipment is available at the dive site to treat injured divers. In doing so, the employer must ensure that the equipment delivers medical-grade O2 that meets the requirements for medical USP oxygen, Type 1, Quality Verification Level A, of CGAG 4.3-2000, Commodity Specification for Oxygen. The equipment delivers this O2 to a transparent mask that covers the injured diver's nose and mouth, and sufficient O2 is available for administration to the injured diver from the time the employer recognizes the symptoms of a diving-related medical emergency until the injured diver reaches a decompression chamber for treatment. Before each day's diving operations, the employer must ensure that at least 2 attendants, either employees or non-employees, qualified in first aid and administering O2 treatment, are available at the dive site to treat diving-related medical emergencies, and verify their qualifications for this task. Diving logs and no decompression tables. Before starting each day's diving operations, the employer must designate an employee or a non-employee to make entries in a diving log, and verify that this designee understands the diving and medical terminology and proper procedures for making correct entries in the diving log. The employer must ensure that the diving log conforms to the requirements specified by paragraph D, Record of Dive, of Section 1910.423, and maintain a record of the dive according to Section 1910.440, Record-keeping requirements. The employer must ensure that a hard copy of the no decompression tables used for the dives, as specified in paragraph 6A of this appendix, is readily available at the dive site, whether or not the divers use dive decompression computers. Diver training. The employer must ensure that each diver receives training that enables the diver to perform work safely and effectively while using open-circuit scubas or rebreathers supplied with nitrox breathing gas mixtures. Accordingly, each diver must be able to demonstrate the ability to perform critical tasks safely and effectively, including, but not limited to, recognizing the effects of breathing excessive CO2 and O2, taking appropriate action after detecting excessive levels of CO2 and O2, and properly evaluating, operating, and maintaining their diving equipment under the diving conditions they encounter. Testing protocol for determining the CO2 limits of rebreather canisters. The employer must ensure that the rebreather manufacturer has used the following procedures for determining that the CO2 sorbent material meets the specifications of the sorbent materials manufacturer. The North Atlantic Treating Organization CO2 Absorbent Activity Test, the ROTAP Shaker and Nested Sieves Test, the Navy Experimental Diving Unit (NEDU) Derived Schlegel Test, and the NEDO Mesh Fit software. The employer must ensure that the rebreather manufacturer has applied the following canister testing materials, methods, procedures, and statistical analyses. Use of a nitrox breathing gas mixture that has an O2 fraction maintained at 0.28, equivalent to 1.488 of O2 at 130 FSW, the maximum O2 concentration permitted at this depth, while operating the rebreather at a maximum depth of 130 FSW. Use of a breathing machine to continuously ventilate the rebreather with breathing gas that is at 100% humidity and warmed to a temperature of 98.6 degrees Fahrenheit 37 degrees Celsius in the heating humidification chamber. Measurement of the O2 concentration of the inhalation breathing gas delivered to the mouthpiece. Testing of the canisters using the 3 ventilation rates listed in Table I below, with the required breathing machine tidal volumes and frequencies, and CO2 injection rates, provided for each ventilation rate. See Table I. Canister testing parameters. When using a work rate, i.e., breathing machine tidal volume and frequency, other than the work rates listed in the table above, addition of the appropriate combinations of ventilation rates and CO2 injection rates, performance of the CO2 injection at a constant, steady, and continuous rate during each testing trial, determination of canister duration using a minimum of 4 water temperatures, including 40, 50, 70, and 90 degrees Fahrenheit, 4.4, 10.0, 21.1, and 32.2 degrees Celsius, respectively, monitoring of the breathing gas temperature at the rebreather mouthpiece, at the Chrome T connector, and ensuring that this temperature conforms to the temperature of a diver's exhaled breath at the water temperature and ventilation rate used during the testing trial. Implementation of at least 8 testing trials for each combination of temperature and ventilation CO2 injection rates, for example, 8 testing trials at 40 degrees Fahrenheit using a ventilation rate of 22.5 lpm at a CO2 injection rate of 0.90 lpm. Allowing the water temperature to vary no more than plus or minus 2.0 degrees Fahrenheit, plus or minus 1.0 degrees C, between each of the 8 testing trials, and no more than plus or minus 1.0 degree F, plus or minus 0.5 degrees C, within each testing trial. Use of the average temperature for each set of 8 testing trials in the statistical analysis of the testing trial results, with the testing trial results being the time taken for the inhaled breathing gas to reach 0.005 ATA of CO2, i.e., the canister duration results. Analysis of the canister duration results using the repeated measure statistics described in NEDU Report 2-99. Specification of the replacement schedule for the CO2 sorbent materials in terms of the lower prediction line, or limit, of the 95% confidence interval, and derivation of replacement schedules only by interpolating among, but not by extrapolating beyond, the depth, water temperatures, and exercise levels used during canister testing.